All right, welcome to this explainer. Today we are officially moving past those experimental AI chatbots and stepping right into the era of production-ready, autonomous agentic workflows. For a long time, building AI agents felt, well, a bit like the Wild West. Developers were piecing together these highly fragmented libraries, trying to basically force large language models to do things they weren't natively designed to do, and then totally struggling to bring those fragile experiments into reliable enterprise production. But with the general availability release of Microsoft Agent Framework 1.0, that entire landscape is completely shifting. We are looking at a profound unification of agent development, and it is a real game changer.
Here's our agenda for today. We're going to quickly cover 1. Chatbots to autonomous agents. 2. The Great Framework Divide. 3. Enter Microsoft Agent Framework. 4. Under the hood of math. 5. Standards and interoperability. And finally 6. From code to cloud. Let's get right into it.
Starting with Section 1. Chatbots to autonomous agents, moving beyond reactive prompts.
We're in the middle of a massive transformation right now. Businesses are shifting from reactive conversational AI, systems that just fetch data when you ask them a question, to actionable, goal-driven agents. For years, we built informational chatbots. You'd ask a question, the bot would give an answer, but then you still had to go and manually execute the actual task. If you've ever drowned in spaghetti code just trying to make a bot do more than simply chat, you feel my pain here. True AI agents require complex, long-running systems that can interpret high-level goals and handle ambiguity without step-by-step human handholding. Basically, we are shifting away from the rigid, rule-based scripts of traditional RPA and moving toward LLMs acting as autonomous reasoning engines that can handle tasks from end to end.
Which brings us to Section 2, the Great Framework Divide, the Developer's Compromise. As developers pushed into this agentic future, they hit a massive wall. The landscape was super fragmented, forcing teams to make a really difficult compromise. Just look at the stark division we used to face. On one side, you had semantic kernel. It was fantastic for deterministic workflows, super secure, governed, strong connector support, and totally enterprise-ready for C#, Java, and Python. But then, on the flip side, you had Autogen. Autogen was the cutting-edge darling for dynamic, multi-agent orchestration and collaborative intelligence, but it was heavily Python first and honestly felt a bit more experimental. So as a developer, you had to choose. Do I want the enterprise stability of semantic kernel or the flexible multi-agent intelligence of Autogen? It literally divided enterprise developers right down the middle.
And that leads us to Section 3. Enter Microsoft Agent Framework, the Great Unifier.
This April 2026 general availability of Microsoft Agent Framework 1.0 is a major milestone because it perfectly unifies those two distinct approaches. Looking at this timeline, you can see how the foundational plumbing of dialogue control started way back with Bot Framework and Power Automate. Then, the LLM breakthrough acted as a catalyst, which split development into those two separate paths we just talked about. But now, it has finally been merged into a single, cohesive, open-source SDK. And the best part is the identical API parity for both .NET and Python. The framework basically takes the enterprise stability and deterministic control of semantic kernel and perfectly fuses it with the dynamic multi-agent reasoning of Autogen into one unified system.
Before we look at the architecture, I really want to highlight this incredibly grounded philosophy from the framework's core design. Quote, "If you can solve the task with deterministic code, do that instead of using an AI agent." I absolutely love this. MAF is essentially the grown-up version of AI orchestration. It doesn't treat AI like a shiny hammer for every single nail. It respects traditional, deterministic code where it works best, and only brings in agentic reasoning when you actually need dynamic intent extraction.
Let's move to Section 4, under the hood of MAF, the core architecture.
The crucial point here is understanding how this framework handles the underlying plumbing, so you can stop wrestling with APIs and focus purely on your app's logic. This diagram brilliantly illustrates the hybrid orchestration of MAF. Notice how the deterministic processing blocks merge seamlessly into the dynamic, LLM-driven nodes, all within a single runtime environment. It acts as an abstraction layer, separating the direct calls to the large language model from the agentic capabilities. So, whether you are running a complex multi-agent handoff or just a simple sequential workflow, you have one unified structure. At its core, the framework relies on a really simple, consistent programming triad: the agent, the tool, and the memory. First, the agent. Agents here are stateful execution units. They aren't just simple prompt wrappers. They maintain conversation threads and manage sessions. Second, the tool. Tools are where you package your domain expertise. These can be straightforward Python or C# functions decorated with markers, so the framework knows exactly how to route LLM responses directly to them. And third, memory. Instead of writing one massive block of code to fetch data, you use modular context providers. You can plug into services like Redis or Memzero to inject real-time data or historical knowledge right before the agent even calls the model.
All of this comes together to build the agentic adaptive loop: reason, plan, act, adapt, and decide. Because MAF agents are truly autonomous, they operate continuously through this cycle. They understand their objectives, design a plan, which might even involve parallel processing for speed, execute the actions, monitor progress with built-in guardrails, and, actually, this is the best part, they initiate sequential fallbacks if issues arise. So, if a tool fails or an API times out, the agent can adapt its plan and try an alternative route, completely on its own, without a human stepping in to fix it.
Okay, Section 5, Standards and Interoperability, an open ecosystem.
Now, with all this built-in power, you might be thinking, great, but what about vendor lock-in? Well, you don't have to compromise on interoperability anymore because MAF is fundamentally built on open standards. By using the Model Context Protocol, or MCP, your agents can dynamically discover and host external tools without you having to write fragile integration code for every single service. Finally, right? Plus, by standardizing agent-to-agent, or A2A communication, your math agents can seamlessly collaborate across completely different platforms. Add in OpenTelemetry for deep observability into every tool call, and it becomes clear this is a highly extensible cloud-agnostic architecture. Run it locally, push it to Azure, or swap out the underlying model for third-party APIs like Anthropic. It's totally up to you.
When we map MAF against alternative frameworks in this table, you can see exactly where it shines. Alternatives like LangGraph are great for complex directed graph workflows, and CrewAI is fantastic for rapid prototyping with role-based delegation, but MAF clearly stands out for regulated environments like finance, healthcare, or government. With its hybrid orchestration, identical .NET and Python parity, and that deep Azure integration, it provides the embedded compliance and auditability features that enterprise deployments absolutely demand, for sure.
Moving on to our final section, Section 6, From Code to Cloud, Enterprise Readiness.
Let's look at the transformational journey of actually deploying these systems, because an agent is really only as good as its ability to scale reliably in production. Notice how MAF sits right in the middle here, acting as the critical bridge in the ecosystem. It takes your locally built code and transitions it incredibly smoothly into a managed, highly scalable runtime. Through the M365 Agents SDK, you can connect your framework to Copilot Studio and various channels while seamlessly tying into Azure AI Foundry on the backend for all the heavy lifting and model management.
Do you know what this means for developers? Zero rewrites. Literally zero. You can build and test your agents entirely locally using the open-source SDK. Then, when you hit publish, the execution logic remains perfectly consistent for production. This completely eliminates deployment friction and debugging overhead. Once you're deployed to Azure AI Foundry, your agents get high availability, scalability, and enterprise security guaranteed via virtual network integration and Entra ID identity management straight out of the box.
The era of disjointed AI experiments is officially fading out, making way for mature, governable, and deeply integrated agentic systems. With the power of Microsoft Agent Framework 1.0 standardizing the chaos, unifying agent development, and bridging the divide between determinism and autonomy, the only question left for us is, what autonomous solution are you going to build next?